The program introduces multiple regression analysis, an extension of simple linear regression that incorporates more than one explanatory variable. Multiple regression is widely used in finance because most economic and financial outcomes are influenced by several factors simultaneously. The model estimates the relationship between a dependent variable and multiple independent variables while holding the effects of other variables constant. This approach allows analysts to isolate the impact of individual risk factors and better understand complex financial relationships. Applications include asset pricing, credit risk modeling, macroeconomic forecasting, and portfolio analysis. Multiple regression therefore provides a more realistic and flexible framework for quantitative financial analysis and decision-making. The program explains that each coefficient in a multiple regression model represents the estimated change in the dependent variable associated with a one-unit change in a specific explanatory variable, assuming all other variables remain constant. This interpretation is essential because financial variables are often correlated with one another. By controlling for additional influences, multiple regression improves the accuracy and explanatory power of statistical models. The program also emphasizes the role of the error term, which captures the variation in the dependent variable not explained by the included regressors. In practical finance, unexplained variation may arise from omitted variables, random market shocks, or unexpected economic developments that influence asset prices and risk exposures. A key focus of topic is the estimation of regression coefficients using ordinary least squares, OLS. OLS selects coefficient estimates that minimize the sum of squared residuals between observed and predicted values. The program highlights that OLS estimators remain unbiased and consistent when the classical regression assumptions are satisfied. However, multiple regression introduces additional challenges such as multicollinearity, where explanatory variables are highly correlated with each other. Multicollinearity can increase the variance of coefficient estimates and reduce statistical reliability. Risk managers and financial analysts must therefore carefully select variables and interpret regression results cautiously when analyzing interconnected economic and market factors within quantitative financial models. Topic focuses on measures of fit used to evaluate the explanatory power and effectiveness of linear regression models. The primary measure discussed is the coefficient of determination, commonly known as R superscript 2. This statistic measures the proportion of total variation in the dependent variable explained by the regression model. Higher R superscript 2 values indicate that the model captures a larger share of observed variability. In financial applications, R superscript 2 is often used to evaluate factor models, benchmark tracking performance, and economic forecasting accuracy. However, the program warns that a high R superscript 2 alone does not guarantee that a model is economically meaningful or statistically reliable, particularly when irrelevant variables are included. The program also introduces adjusted R superscript 2, which modifies the standard R superscript 2 measure by accounting for the number of explanatory variables included in the model. Unlike ordinary R superscript 2, adjusted R superscript 2 may decrease if additional variables fail to improve explanatory power sufficiently. This adjustment helps prevent overfitting, where models become excessively complex and perform poorly on new data despite fitting historical observations closely. In quantitative finance, overfitting is a significant concern because financial relationships often change over time and may not persist in future market environments. Adjusted R superscript 2 therefore provides a more balanced evaluation of model quality by considering both explanatory strength and model simplicity. Overall, topics demonstrate how multiple regression models provide powerful tools for analyzing complex financial relationships and evaluating risk factors simultaneously. The program highlights the importance of interpreting coefficients correctly, assessing model assumptions carefully, and using appropriate measures of fit to evaluate model performance. Multiple regression supports a wide range of applications, including portfolio construction, factor investing, economic forecasting, and enterprise risk management. By understanding the strengths and limitations of regression-based analysis, candidates develop practical quantitative skills necessary for interpreting financial data, constructing predictive models, and making informed decisions under uncertainty within modern financial markets and institutions.